Hello students, welcome to all of you in SAM Alchemy classes. Today in this segment we will discuss about hydrolysis of epoxides. What are epoxides and how epoxides are formed? So first we will discuss about the formation of epoxides. When alkene RCH double bond CH2 alkene reacts with per acids like benzoic acid. When alkene reacts with per acids, then elimination of carboxylic, the acid used, elimination of benzoic acid, and one oxygen get attached with the linked carbon with double bonded in such a way that it is in the sharing with both the carbon of double bonded. This group is called epoxide. This is epoxide. So epoxide are formed when per acid reacts with unsaturated hydrocarbon like alkene, and this epoxide after hydrolysis means reacts with water HOH, this bond get break and diols are obtained. Again diols are obtained. These are glycols, diols. But these diols are trans by nature. These are trans by nature if asymmetric carbon is present. So what is hydrolysis of epoxide? The epoxides are formed when per acid like performic acid, perbenzoic acid, etc. reacts with alkene. Then epoxide is formed where the peroxy oxygen get linked with the commonly with both the double bonded carbon, and the cyclic epoxide is formed that after hydrolysis results glycol. Since when this bond get break, OH get attached on the two opposite sides. That's why trans diols are obtained when alkene reacts with per acids. If cis alkene reacts, then trans diols are obtained, and when trans alkene react, then cis diols are obtained. So this is the difference. When cis alkene reacts, cis form of alkene reacts with per acids, epoxide is formed. After hydrolysis, trans diols means glycols are obtained. So just see now the complete reaction, how glycols are formed. Like CH2 double bond CH2 with C6H5 C triple OH per benzoic acid. We can note this perbenzoic acid like H single bond O single bond O single bond C double bond O single bond C6H5. This is C6H5 C triple OH. Here one peroxy linkage is present. That's why it's called perbenzoic acid. Perbenzoic acid, this peroxy oxygen get attached here with elimination of benzoic acid C6H5 COOH. Now one oxygen get attached here, CH2 single bond CH2, and this oxygen make a common bond with the double bonded carbon on both the sides, and this is called epoxide. Epoxide, when hydrolysis is carried out, then it gives CH2OH single bond CH2OH ethylene glycol. Ethylene glycol is obtained like this. If we take CH3 CH double bond CH2, then C6H5 CO2OH perbenzoic acid reacts elimination of C6H5 COOH, benzoic acid eliminated. Now epoxide is formed, epoxy CH2 common epoxy is formed. After hydrolysis reacts with H2O, it gives CH3 CHOH single bond CH2OH. This is propane 1,2-diol, again glycol is formed. If we take the alkene that results asymmetric carbon containing diols, and it may give the cis form or transform like CH3 CH double bond CH3. This if cis form is taken, cis form like this in geometrical isomerism आपने पढ़ी होगी, this is the cis form. When both the identical group attached with a double bonded carbon are at the same side, then it is called cis form. This is the cis form of butene. Now reacts with perbenzoic acid, so it results two products. Since both the OS get attached opposite to each other, that's why epoxy supported by hydrolysis. Epoxy supported by hydrolysis, it gives CH3 OH, तो अपोजिट में OH HH, या तो ये बन सकता है या CH3 अगर हम OH इधर को लें तो नेक्स्ट में OH अपोजिट में अटैच इधर आ जाएगा, देन HH. ब्यूटेन 2,3 in both the cases diol, ब्यूटेन 2,3-diol. बट हम इसकी स्टीरियोकेमिस्ट्री अगर देखें, इसके स्टीरियो आइसोमर्स को डिस्कस करें, सो दिस इज कायरल कार्बन here if we consider rotation of plane polarized light from H towards OH through CH3, then this is clockwise direction, this is dextroform. When H towards OH through CH3, anti-clockwise direction, Leo-form. So both are mirror image to each other, non-superimposable to each other. That's why these dextro and Leo form are enantiomers or enantiomorphs, since when cis isomer of an alkene gives dextro and Leo mixture, so overall mixture is formed is called racemic mixture. So whenever cis form of an alkene reacts with perbenzoic acid or per acids, racemic mixture is obtained where dextro and levo form are present. So these are separated under different techniques through at their different boiling points. So racemic mixtures are isolated and again converts into dextro and levo forms separately. This is called resolution. Racemic mixture, when both the optically active forms are separated from racemic mixture, this process is called resolution. So when an cis form of alkene reacts with per acids, racemic mixture is obtained because cis form gives trans diols. So dextro and levo in mixture are obtained. Both are enantiomers, mirror image to each other. But if we take transform, when we take transform of an alkene like this, CH3 CH double bond CH single bond CH3 C double bond C CH3 CH3 H H. This is transform. Transform when reacts with peracid, then it gives cis form. It gives cis diols. This is CH3, CH3. Both the OH will be on the same side. On the same side. Like here, CH3, CH3. Both the OH will be on the same side. Whether above to plane of paper or below to plane of paper. In both the cases, here symmetry is present. Plane of symmetry. And both can overlap to each other. Half part can overlap to each other. So this is called mesoform. Mesoform. So when transform of an alkene reacts with peracids, then mesoform is obtained. It is optically inactive. Mesoform is optically inactive. And it cannot be separated into dextro and levo, but prior to it we have discussed if cis form of an alkene is taken, then trans diols are formed. So dextro and levo are present in mixture is called racemic mixture. Racemic mixture can be converted into optically active dextro and levo. Resultant solution will be optically inactive because racemic mixture is also optically inactive but can be resolved into dextro and levo, while meso, due to internal compensation, it can't be separated into dextro and levo forms. Due to presence of symmetry, half part of molecule can overlap or superimpose to another half part. That's why this is optically inactive. Half part rotate ppl in clockwise direction, while next half in anti-clockwise direction. Same is here in anti-clockwise direction, in clockwise direction. So both the effects neutralizes to each other and resulting solution becomes optically inactive. So this is all about related to hydrolysis of epoxides. Hydrolysis of epoxides results racemic mixture when cis isomer is taken and mesoform when trans isomer is taken. So students, the epoxide hydrolysis is completed. Thank you everybody.